Hi, Assalamualaikum. My name is Suhaila binti Yaakob Elias Othman and my magic number is CE180014. And I'm here today we present my project FYP2, which is my title Smart Flood Prediction System using Blink app. So this is my hardware component and also my prototype that I'm used for this project. So as we know, in Malaysia, floods are caused by natural disaster that cannot be avoided, and it is usually happen during heavy monsoon rainfall, intense convection rainstorm, poor drainage, and it affected life of human, animals, and properties. So this is a graph which is according with the report from the Department of Irrigation and Drainage Malaysia and Ministry of Environment and Water about the total number of flood incidents during 2019. In general, all states in Malaysia experienced flood through 2019. State that the most frequently hit by flood was Sarawak, which is 118 flood incident, and followed by the state of Selangor, which is a 93 incident. And lastly, wilayah Persekutuan Labuan recorded the least number of flood at 6 incident only. So from that, we know the problem statement, which is most of the existing system that has developed are only focused on a certain area. Furthermore, majority of the society cannot monitor and figure out how to solve the problem of the flood since they did not have any information and data about the weather condition to predict when it is going to happen. So, when we have this technology, the public who has internet access can get early warning and monitor what is happening and predict if there is any upcoming flood on the mobile app. So from that, this is my objective of the study, which is design and develop a flood monitoring system and notify the user using the Arduino. And second, to interface water level detector sensor over the internet or Blink app. And lastly, to estimate the possibility of flood occurrence based on data gathered from the system. So from the objective, this is my scope, which is to build a hardware and software system, monitor the water level in a controlled environment. And then I'm using the MCU microcontroller and Blink app for this project, which is the main component. And lastly, use the data that collected from the Blink application to do the prediction. This is the flowchart. The process start when the ultrasonic sensor measure the water level and the collected data from the sensor will be forwarded microcontroller and the data will display in the application. Then the data will be analyzed and flood status will display on LCD and Blink app based on the data of water level. And then the LED will be turned on to indicate the water level. If the water level reach at dangerous level, which is red, which is a dangerous condition, so the red LED will turn on and the buzzer will be automatically sound, so that the local people will get ready to prepare before the flood is occur. From this project, I'm make a 3 condition, which is high condition, normal condition, and dangerous condition, which is the dangerous condition is less than 8 cm and normal condition is more than 20 cm, and this is not less than 7 and less than 20 cm. So this is the block diagram, which is from the node MCU that will be connected to the LED, buzzer, and also LCD display. And then ultrasonic sensor will be connected to the node MCU. So from the node MCU, the data will be transferred to the Blink app. This is my hardware design and also interface of Blink app, which is my hardware design. The main component is a node MCU, ultrasonic sensor, LED, buzzer, and also LCD display. So here I will play my demo. Okay, thank you for watching. So this is my result from my experiment, which is as I stated before, I'm used the ultrasonic sensor to measure the water level. So which is in three condition: normal, high, and also dangerous. For this, this is show that the volume of water level is 3 cm with a height distance from the sensor is 23 cm. For this experiment, the normal reading has been preset to not more than 20 cm, and the LED will light up green, and the data will be collected as long as the water is filled in the container. So this is a high condition. For the high condition, the LED light will be turned red, but the buzzer not been activated, and the minimum reading for high condition is less than 20 cm but not less than 8 cm. However, the sensor reading are not always the case because there are splash of water sensor surface, and the water level sometimes increase and then back to the normal. So lastly, this is a dangerous condition, which is 4 cm. For the maximum ultrasonic sensor can measure is 2 cm. So if continue, the data will be not accurate. In the dangerous condition, the LED will be turned red, and also the alarm will be automatically sound. So from that we get the graph, which is the graph is the first graph is we take from the serial monitor from the Arduino, which is as we can see why is increase decrease because this is occur when water splash on the sensor surface, so that the reading immediately return to normal back, and the data still continue reading. This is the second graph is a live graph from the Blink application. The graph from the Blink application also, after finish the experiment, the data from this graph can send to the email in the Excel. So from that we can do the graph. So from the experiment, I'm do some estimation, which is by using the mathematical formula for the cylinder, which is how to calculate volume, which is using pi r square h. So I get the total volume for the cylinder, and this is estimate water level using the same formula, but I'm use half of the cylinder because the river is big. So I'm estimate is half of the cylinder. This is the water level that I get from public info budget, which is there have 4 level: normal level, alert level, warning level, and dangerous level. So the total volume already set in the public info budget, which is 100,3935. So from that we don't know the height. So I need to calculate the height first. So the radius I'm take the water level condition. So after calculate we get the height. So from that we want to know the volume of the water level when it is reached in a dangerous level in 5 meter. So from that we calculate and then get the volume of the water level. And lastly, I'm also do the prediction of the probability water overflow using the rate of change formula. So the data from the graph are based on the experiment that's performed for this project, and the predicted time for water to fill the container using the formula of rate of change. So we get the answer, and then after that I'm estimate that the time that will be that the time that the water will fill the container is 130 seconds, which is the uh, the height of the height of the height of the container is 26 cm. So from that we know the time to fill the container is 130 seconds. So as the conclusion, the proposed design prototype has been successfully developed, test with the system functioning properly according to a general workflow that can detect water level rise and then display water level measurement on an LCD screen. And the IoT system employed enable water level monitoring where data is delivered using the Blink app. So for my recommendation for my project, I hope that in the future we will use another new IoT to modify this project like TeamSpeak, because actually my project is used the TeamSpeak, but during that not cannot be used because it is unstable technology. So I think that's all from my present. Thank you.